Hi. So in the last video, we talked about creating variables. So before I start talking about today's content, I want to review the types of variables, the data types that we learned last class. So we said that there are 4 data types that we can use for whole numbers. And if we start thinking from smallest to biggest, the first one was byte. And we said that can store about, a number between -128 and 127. So we said about 100, plus or minus. And then we said after byte, there is short. And that can store a number up to about 32,000 plus or minus. And then we said byte short and then int. And that can store a bigger number up to about 2 billion plus or minus. And then there's long. And that's usually used for big numbers, and that can store bigger numbers. And we just said we need to make sure that we put an L in there to make sure it's a long. So those were the 4 data types for whole numbers: byte, short, int, long. Repeat them several times: byte, short, int, long, byte, short, int, long. And then we said there are 2 for decimal numbers. And when we talk about decimal numbers, they're called floating point numbers in Java. And we said there are 2 types. There's float, and we need to put an F when we're creating that variable, and then there is double. And we said the difference between them is that floats are single precision. They can store up to 7 digits, 7 significant digits. And double can store up to 15 significant. That's the difference. If you need more significant digits, you go with a double. If you don't need that many significant digits, you can use a float and you save RAM space. So those were for storing numbers. And then there we said to store 1 character, we use a char. And it can be any character on the keyboard. It can even be the new line, like the enter. We said that's the /n. It can be the tab, which is /t. So those are all characters on the keyboard. And then finally, we said there is the last one, the last primitive data type, which is Boolean, for choosing true or false, for storing true or false. So we said Boolean have money equal to true, Boolean paid rent equal to false. And we said that we can print those Boolean variables. So I can say system.out.println. For example, my salary is plus salary plus, let's say, put a new line in there, and then put yours is plus, let's say, salary too. And so that will print our variables for us. And it is very important that you practice with me. So I highly suggest when you're watching these videos that you have your NetBeans open. And as I'm typing them, pause the video and try these yourself. It's very easy to watch and everything makes sense when you're watching, but it's a different story when you're typing it yourself. So you only learn when you type yourself. So I highly suggest that you type these, this code that I'm writing along with me for extra practice. So what we want to do today is we've created those variables. We want to start using them. So we created variables. We know how to print them. We want to be able to use these variables in arithmetic operators. So if I have some numbers, for example, I have here int x is 10, y is 5. So here I'm creating 2 variables on the same line, x is 10, y is 5. And I want to do some mathematical operations. Well, I can do the addition, subtraction, multiplication, division, and then there's the percent sign, which is called the modulus operator, and we're going to talk about it in a minute. So if I say print me x plus y, well, x is 10, y is 5. So 10 plus 5 is 15. I'm going to get 15 printed out. If I say print me x minus y, it's going to say, well, 10 minus 5 is 5. If I say x times y, x is 10, y is 5, So 10 times 5 is 50. If I say divide x by y, it's going to say 10 divided by 5 is 2. And finally, the modulus operator, the percent sign. That percent sign, what it does, it gives us the remainder. So if I divide 10 by 5, I get 2, remainder 0. So I'm going to get a 0 printed back to me. So let's try these out. So here I have, for example, let's create a byte. 10 and y equal to 3. And what I want to do now is I want to print the remainder. So here, if I say print me 10 divided by 3 and give me the remainder, well, when I divide 10 by 3, the answer should be 3 remainder 1. So I should get a 1 printed back. And this is what the modulus operator does. It gives you back the remainder. So it's a special operator that is helpful. Now, when we're doing those mathematical operators, here we are printing them, but we can also store them in variables. So I can say, for example, int a equal to 9, b equal to 8, and I want another variable, let's say int equal to a times b. So you can create variables also that store the output of those mathematical operators. And if I print this, you guys know what 9 times 8 is? I should get 72. Multiply a times b, 9 times 8, I will get 72. So you can use the mathematical operators, the addition, subtraction, multiplication, division, modulus, and print statements. You can also use them and store the information back in a variable and do whatever you need to do with that variable. Now, there's one thing that I want us to try, and then I'll explain a small problem with arithmetic operators. So here, let's say I want to do, I have x is 10, y is 3, and I want to print the division. So if I try dividing 10 by 3, sorry, by y, which is 3, let's do that on a calculator. Let's see what Java gives me until the calculator comes back up. So if I try dividing 10 by 3, I get a 3. But I know that 9 divided by 3. So I know that 9 divided by 3 is equal to 3. Why is 10 divided by 3 equal to 3? That doesn't make sense. It should be 10 divided by 3 should be 3.333. What happened? Something is wrong, right? Well, something is wrong, but this is how Java behaves. If we go back and start looking at the data types. So when I look at the data types, x, byte, which is a whole number, y is also a byte in this case, which is a whole number. And so when Java starts doing this mathematical operation, the division, it says x divided by y, I have a whole number divided by a whole number. So my answer will be a whole number. It's going to be a whole number. So what it does, it takes the 3.3 and it throws away the decimal part. So whatever comes after the decimal, it throws away. Now, let's see, is it rounding or is it throwing away? So let's do something else. Let's try 11 divided by 3. Okay, so if I go to my calculator and I say 11 divided by 3, it's 3.66. So, you know, if you want to round it, it's going to be 3.67 or 3.7 or 4, right? So it should be 3.67. Well, what does Java give us back? Well, it gives us back a 3. So whether I'm doing 10 divided by 3 or 11 divided by 3, it's giving me back a 3. It throws away, so 11 by 3 gives me a 3. Again, the decimal part is thrown away. It doesn't do any rounding. And this is going to be true with any of the whole numbers. So if I try byte or short or int or long, it's going to give me the same thing. So anytime you do a whole number divided by a whole number, know that you're going to get a whole number back. You're not going to get the decimal number that you're expecting. So what are the solutions? We need solutions for this. This is not a good thing. If I say, 1 divided by 2, I'm trying to find the area of a rectangle. And sorry, a triangle, and I'm doing, 1 divided by 2 times something. 1 divided by 2 is not going to give me 0.5. It's going to give me a 0, which is really, really bad. All my math will be 0. So how do I fix that? Well, if you're using numbers, it's easy. You can come and you can say, well, I need to make sure one of them is not a whole number. So number 1, make sure one of the numbers is a decimal, not a whole number. So I can come to the 1 and I can say, make it a 1.0. And as long as one of them is not a whole number, you will get a decimal. So if you have a decimal divided by a whole number, you will get a decimal. So it sees, oh, this is the most precise. I need to be precise like this. So you're going to get a decimal. And it doesn't matter whether you put the decimal on the first number or the last number. So if I say 1 divided by 2.0, I'm going to get the same answer back. Both of them will give me a good answer of 0.5. So this is a good solution. Okay, well, this is a solution if I have numbers. Well, what if I have variables? So now let's talk about variables. If I have, let's say again, I have int r equal to 10, or let's r equal 1, and y equal to 2. And again, I'm doing my system dot out dot println, and I think I used y before, so let's make it k. Okay, and I have here r divided by k. Well, here it's going to give me a whole number divided by whole number. I'm going to get a 0. So the solution here, number 2, is change your variable to be a decimal number. So here, instead of using int, do is I can make it a float. So I can say float r equal to 1, a equal to 2. And this line, I want it shouldn't be commented out. Okay, so if I change them to a float, it'll work. So if I have variables, if I have literals, I can make sure the literals are decimal numbers. If I have variables, I can make sure that they are decimals, make them floats. Okay, well, that's a nice solution. However, that solution wastes space. Remember, a byte takes just 1 byte. A float takes 4 bytes in RAM. So now I'm wasting 3 bytes in RAM. I wasted 3 for variable r. I wasted 3 for the variable k. So I just wasted 6 bytes of RAM. And as your programs get bigger, this wasting of space is going to get bigger. So this is a good solution for now, but it's not the best solution. So we want a better solution. So there's another solution, which is called casting. And what casting means is I'm going to treat a variable as another temporarily. So what does that mean? So here I'm going to create my other variables again. Let's use w this time, and let's use e. And let's put our system.out.println statement again. And this time I'm dividing w by e. Let's verify that it's going to give me a 0. Okay, and it does. So what casting does, it says, yes, I know that w is an int, but what I want you to do, just for the sake of this call, is I want you to treat it as a float. And so I'm just going to put extra spaces here, and these spaces are not needed, but they're just for you to see what's going on. So I'm coming to the w variable, and in parentheses before, I'll put float. And what this tells Java to do is I want you to treat w as if it was a float. And so now if this is a float divided by a whole number, I'm going to get a float answer out of it. And so I do get a 0.5. Okay, you could do that with a W, or you could do it with the E. So as long as one of the variables is a float, it'll work. So I can come, instead of putting it before the W, I'll put it before the E. And again, those extra spaces that I'm putting are not needed. They're just for you to see what's going on. So this is called casting, and it's really nice where you're temporarily just treating this variable as if it was a decimal. Now, if I want to make sure it never changed it, I'll print W divided by E again, and you'll see that it's still a 0. So W was never changed. E was never changed. So this casting that I just did on those two lines didn't change the value. They just treated W as if it was a float just for this operation. Okay, but the value stored in W is not changed. The amount of RAM that W is taking is not changed. So this is a good solution. I'm not wasting space. That's good. We never want to waste space. Okay, so again, this is a summary of the problem that we run into when we have whole numbers divided by whole numbers. There are 3 solutions that we can do. One is make sure that one of the literals is the decimal number, if you can do that. Now, if you're working with variables, that's not possible. So you can go with the bad solution, which is make sure your variables are floats or doubles and waste space, but that's a bad solution. Okay, so this is bad solution. You don't want to waste space. And the good solution is doing something called casting, where you're not wasting space. You come to a variable and you say, I want you to treat this variable as if it was a decimal just for this operation. And this will solve the problem of division when you have whole numbers.